The US Navy's decision to reset its frigate program and how it went about doing so mark a major shift in how it builds warships. After more than a decade of disappointments with surface combatants acquisition, from the littoral combat ship to the cancelled Constellation class, the new FFX frigate represents an explicit attempt to prioritize production speed, affordability, and feasibility over ambition. The result is a design philosophy that accepts limitations by design and leans heavily on customs weapons and payloads in containers to compensate for deliberately restrained built-in capabilities on the ships. Whether this approach succeeds will depend less on what the frigate is on paper than on whether the Navy can finally discipline itself to build what it says it wants. The new FFX frigate is the Navy's attempt to escape the trap that ended in the death of the Constellation-class frigate. Rather than starting from a foreign combatant and reshaping it beyond recognition, like what the US Navy has done with the Frame and the Constellation, the service has chosen to adapt a domestic hull with a long service record. The Coast Guard's Legend-class national security cutter. This choice is not about combat power, it is about certainty. The hull form is well understood and designed to operate in blue water conditions for long deployment. At roughly 127 meters in length and around 4,700 tons displacement, it is significantly smaller than the cancelled Constellation, and that is the point. The Navy is no longer trying to build a small destroyer. It is attempting to build a frigate in the traditional sense, a ship optimized for endurance, presence, and more specialized tasks, rather than high-end combat across all domains. This shift reflects a recognition that the Navy's surface fleet has become dangerously top-heavy. Arleigh-Burke-class destroyers are expected to do everything, from ballistic missile defense to counter-narcotics patrols, while cruisers retire and the LCS struggles to find a coherent role. In this context, the absence of a reliable, low-cost platform is not merely inefficient, it is structurally destabilizing. The FFX is meant to absorb missions that do not require the full sensor and weapon suites of a large surface combatant, freeing destroyers for tasks where their capabilities are truly needed. Crucially, the FFX is being designed around the idea that less is more, at least initially. The first ships will have modest integrated armament, a 57mm main gun, a points defense missile launcher for close-range air threat, a medium-range surveillance radar, electronic warfare systems, decoys, and facilities for helicopters and uncrewed aircraft. There is no vertical launch system, at least not built in, no area air defense capability, and no pretense that the ship can operate independently in heavily contested environments. This is not an oversight. It is a deliberate trade-off. By excluding complex systems that drives cost, power demand, cooling requirements, and design risk, the Navy is trying to lock the design early and avoid the cascading changes that destroyed the Constellation. The same logic underpins the Navy's interest in modular construction to accelerate production. Modular shipbuilding is not new, but its application to a relatively simple surface combatant is a departure from past practice. The concept involves building large sections of a ship, complete with systems, cabling, and internal fittings at multiple facilities, then assembling them at a lead yard. This approach has been refined over decades in submarine construction, where modules such as command and control spaces are effectively complete before they are joined to the hull. The benefit is threefold. First, it dramatically reduces the workload at the final assembly yard, which becomes more of an integrator than a traditional builder. Second, it allows the Navy to tap into a much broader industrial base, including smaller yards that might otherwise be excluded from major combatant programs. Third, it allows individual shipyards to specialize in producing one component, thereby achieving efficiencies and economies of scale. For the FFX, modular construction is explicitly tied to the goal of speed. The lead ship will not fully exploit distributed construction, but subsequent hulls are intended to do so. By spreading module fabrication across multiple yards, potentially dozens, the Navy hopes to compress build timelines and increase throughput. In effect, this turns shipbuilding into a parallel process rather than a serial one. Instead of waiting for a single yard to complete each stage in sequence, multiple components can be built simultaneously, then brought together for final assembly. If executed properly, this approach could shave years off delivery schedules. There's also a political and strategic dimension to modular construction. Distributing work across more yards reduces program vulnerability by tying it to more regions and constituents. It also offers a partial answer to the stark imbalance between US and Chinese shipbuilding capacity. While modular construction will not close that gap on its own, it allows the Navy to extract more output from a constrained industrial base. In extremis, the concept could even extend to foreign partners building non-sensitive modules, although this introduces significant logistical, security, and supply chain challenges. However, there still remains a problem of a lack of capabilities built into the basic FFX. This is where containerized equipment enter the picture. Rather than embedding all systems into the ship from the outset, the Navy intends to rely heavily on containerized weapons and mission systems that can be installed on the frigate's open deck areas, particularly at the stern. These containers are standardized in form, but not in function. Inside them can be anti-ship missile launchers, short-range surface-to-air missiles, counter-drone systems, or even elements of an anti-submarine warfare suite. The advantage of containerization is flexibility and the mitigation of risk. Systems placed in containers can be developed, tested, and upgraded largely independently of the ship itself. If a particular payload underperforms or becomes obsolete, it can be removed without redesigning the entire ship. This decoupling of ship and system is central to the Navy's effort to avoid another spiral of change orders. The ship becomes a stable platform. Capabilities evolve through what is carried aboard it. In practical terms, containerized weapons are intended to compensate for the frigate's limited built-in firepower. The Navy has highlighted options such as deck-mounted anti-ship missiles and large numbers of short-range missiles optimized for counter-drone defense. While these do not replace a vertical launch system, they do provide meaningful offensive and defensive capability at a fraction of the integration cost. For many of the missions the frigate is expected to perform, presence operations, escorts in permissive environments, surface warfare against lightly defended targets, this may be sufficient. Containerization also aligns with the Navy's emphasis on rapid learning and adaptation. Rather than attempting to predict all future requirements at the design stage, the service is betting that it can iterate in service. Early FFX deployments will reveal which capabilities are most valuable and which are superfluous. Containerized payloads allow these lessons to be incorporated quickly, without waiting for a new flight of ships or a major refit. In theory, this creates a feedback loop that improves capability while keeping the underlying platform unchanged. There are, of course, limits to what containers can achieve. A ship can only carry a finite number of payloads in only one configuration, and possibly even just a few containers at a time. A frigate loaded for surface warfare cannot simultaneously carry a full anti-submarine suite, nor can container systems fully substitute for deeply integrated sensor and weapons when it comes to area air defense or high-end anti-submarine operations. The Navy appears to accept these limitations, implicitly acknowledging that the FFX as frigate will operate as part of a larger force rather than as a standalone surface combatant. This acceptance is central to the program's thesis. The frigate is not designed to be everything. It is designed to be built quickly, in numbers, with minimal risk. Its value lies in what it enables elsewhere in the fleet. Every mission it absorbs is one less task assigned to a destroyer. Every hull delivered on time is a marginal improvement in readiness and presence. In this sense, the FFX is less a weapon system than a force structure tool. The emphasis on speed and risk reduction is evident in the Navy's insistence that the design is effectively complete and that engineering changes will be tightly controlled. This is a stark departure from past practice, where requirements were allowed to evolve deep into construction. Whether this discipline can be maintained remains an open question. The history of naval acquisition is littered with programs that began with similar vows of restraint. One reservation is that the frigate's design philosophy inevitably raises uncomfortable comparisons with the littoral combat ship. As a concept, FFX risk appearing like a blue water cousin of the LCS rather than a true successor to traditional frigates. Both rely on modest, built-in armament, emphasize modular or container weapons to fill capability gaps, and accept limited air defense and anti-submarine capabilities as a baseline. The LCS experience demonstrated that modularity, while attractive on paper, does not automatically translate into flexibility, especially when ships deploy with largely fixed configurations. There is a real concern that FFX could repeat this pattern, a ship that is theoretically adaptable but practically constrained, and whose limited organic power restricts its ability to operate independently. The Navy insists that the FFX differs fundamentally from the LCS, but the conceptual overlap is too difficult to ignore. Yet, there are reasons to think that the context has changed. The Navy is facing simultaneous pressures: rising cost, shrinking ship counts, and an increasingly demanding strategic environment. There is less tolerance for elegance failure and less patience for programs that promise future capability at the expense of present capability. The FFX reflects a sober assessment of what the service can realistically build. In the end, the new frigate's success will be measured by whether it is delivered on time, within cost, and in sufficient numbers. Modular construction and containerized payloads are means to that end, not ends in themselves. They are tools to streamline production, control risk, and restore a degree of balance to the surface fleet. If the Navy can resist the urge to turn the FFX into something it was never meant to be, it may finally achieve a modest but crucial victory, building a warship that is good enough, soon enough, and cheap enough to matter.